Imagine you have two machine learning models and you want to know which one performs better, not just by a little, but truly significantly. How do you move beyond simple accuracy numbers to make a statistically sound comparison? In machine learning, a test statistic is a single value calculated from your data that quantifies the evidence against a null hypothesis. This hypothesis usually states there is no significant difference or effect. For instance, that two models perform equally well or that a model's performance is due to random chance. The core idea behind a test statistic is to provide a standardized measure of how for your observed data deviates from what you would expect if the null hypothesis were true. It transforms your raw performance metrics, like accuracy or F1 score, into a scale that can be compared against a known statistical distribution. This transformation allows you to determine the probability of observing such a result purely by chance, which is known as the p-value. The larger the test statistic, generally, the stronger the evidence against the null hypothesis. Using a test statistic involves a few key steps. First, you define your null and alternative hypotheses. For example, your null hypothesis might be that Model A and Model B have identical performance on a given metric. Next, you select an appropriate test statistic based on your data type and experimental design, such as a z-score, a t-score, or a chi-squared statistic. You then calculate this statistic from your model's performance on your test sets. Finally, you compare your calculated test statistic to a critical value from its sampling distribution to decide whether to reject or fail to reject your null hypothesis. This process is fundamental to statistical hypothesis testing, providing a robust framework for making informed decisions about model effectiveness. For instance, when comparing two classification models, you might use McNemar's test, which generates a chi-squared test statistic to compare their error rates on the same data. This specialized test statistic accounts for the fact that the models are evaluated on identical samples, providing a more precise comparison. Ultimately, understanding and properly utilizing test statistics empowers you to move beyond anecdotal evidence or simple numerical comparisons. It provides a rigorous, data-driven method to assess the true significance of your model's performance, allowing you to confidently select superior models and make reliable statements about their efficacy in real-world applications.